Good evening to all of you. Good afternoon to everybody. Welcome you guys. Welcome you all. How we are doing, everybody? I think we are live. So first of all, do check करके बोलिए now whether this is audio video is clear to all of you. Do check करके comment करके बोलिए now here. Is the audio video is clear to everybody? Yes, fine. Thank you to all of you. So actually sorry for the delay. ऑडियो वीडियो इज क्लियर टू एवरीबॉडी? टेल मी फर्स्ट ऑफ ऑल. ठीक है, चलिए. सो चलो आज का सेशन हम शुरू करेगा. Right. So first of all, you can see this thing here. Is my audio video clear to everybody? तो चलो आज का सेशन हम शुरू करेगा. सबसे पहले बोलिए now here you can have a look at now here. And so this Unacademy, so there is a 12 months का ऑफर चल रहा अभी. So you can see now 12 months के लिए केवल 9999 only. So 9 12,999 only. With this you can get the 12 months का subscription आपको मिलेगा. So to enroll for it you can use the code of BV Reddy and use the code of BV Reddy to avail these great opportunities. So chalo, let's continue our discussions. And so this all India mock test, which is on the 18th of December, we have two slots are there. One is at 9:30 a.m. The other one is 2:30 p.m. With this you will get to know where you stand in entire India of the GATE 2026 rankers. Don't miss it. Right. Now these are the rankers from Unacademy. So you can see now ESC 2025 ka rankers. And so you can have a look at now here. You can start the GATE. So test series भी आपको मिलेगा GATE and ESC का. You can have a look at now from December 15th onwards. You can have a look at. Now so we starting the 2027 का batches and 28 का batches भी हमने launch किया. You can have a look at these batches. Unacademy starters kit which is available. You can utilize this thing. And so here we have West Bengal Electricity Department का batch भी हमने launch किया. You can see now officer call. Yes, crash course and crash course. So this is for you can have a look at now here. So Aditya Kanwal so नया batch शुरू किया. Nakshatra batch. And another great feature of Unacademy is Unacademy Una. With this you can have the direct interaction with the AI tool. We have three different modes you can see now: voice mode, quiz mode, smart summaries. Right. So you can have a look at now. Now plus subscription as well as what tell me now here iconic subscription. Plus में आपको क्या चीज मिलेगा? Top educators classes मिलेगा, live doubt solving evaluated courses and structured courses, like quiz, unlimited access. इसके साथ iconic में आपको पर्सनल कोच भी मिलेगा एंड 1-to-1 मेंटरशिप भी मिलेगा एंड इसके साथ फिजिकल नोट्स भी आपको मिलेगा. Right, so you can start your serious preparation with the Unacademy to achieve your dreams. We are there for you to provide you the best knowledge. So चलो आज का सेशन हम शुरू करेगा. एंड अगर आपने ध्यान से देखा तो प्रीवियसली what the talk what we have completed, you can see previously we have completed so coordinate system हमने डिस्कस किया and this is the third lecture. Coordinate system vector calculus completed. चार्ज डिस्ट्रीब्यूशन यहाँ तक हमने कंप्लीट किया ना. नाउ टेक दिस वन, दिस प्रॉब्लम and take this problem. So here they given, so this row we given which is given as 4/3. So cos square theta sin square phi into r square plus 1. So we need to find out what tell me now here, the total charge within the universe. So means they given the volume charge density, we need to get the charge. How we can get, to tell me now here, that is volume integration of rho v into dv. Volume integration of rho v into dv. So you can see now here. So then we can say that is Q, which is given as volume integral of rho v is how much given? 4 by 3 cos squared theta sin squared phi by r squared into r squared plus 1 and dv. The spherical system dv given as what I mean now? Spherical system, the elements are, we have r comma theta comma phi. So change in length along r is dr, along theta is what, tell me now? R d theta, along phi is what, tell me now? That is r sin theta into d phi. So you can tell me now, that is r squared sin theta dr d theta and d phi. So from this q is equal to, now this is 4 by 3 is a constant integral of, so r square will get cancelled. So now we can write the integration theta. What is the r limits? We'll see first. What is this r limits are? 0 to infinity. R terms we have 1 by 1 plus r square into dr integral of theta. Theta limits are what, tell me now? 0 to pi, and theta terms are what? Cos squared theta into sin theta d theta, and phi limits are what, tell me now? 0 to 2 pi, so which is given as sin square phi into d phi. Now let's simplify now. So then which is given as, that is 4 by 3 into 1 by 1 plus r square. So integration is what, tell me now? Tan inverse. Tan inverse of r, limits are 0 to infinity. So integration of cos square. Yes, now here this could be given as what I can say, cos square. So this is integral of, we can say here, f of x power n into f dash of x, and which is equal to what, tell me? F of x power n plus 1 by n plus 1. I can use these relations. Here f of x is what, tell me? F of x is cos theta. Now what is the f dash x here? Derivative of cos, which will be equal to minus sin theta na? And which is equal to minus sin theta, right? So you can tell me now from this, f dash of x, which is equal to, so f dash of x, which will come to be a, now I can say this is minus of cos theta q by 3. Limits are what we can say now here, 0 to pi. Next, here we have this even function na. Even function property we know, sin square phi, which is the even function. Even function ka property we know. What is the even function? You tell me now here. So this is integral. So this is phi is from 0 to 2 pi. I can say 2 times of pi, I can say. So this is sin square phi into d phi. Again one more time, even function property, 2 into 2, so it is a 4 na. 4 integral phi limits are 0 to pi by 2 and into what I'll get, you tell me now, sine square phi into d phi. Now, so this we can say this as 4 into integral phi is from 0 to pi by 2, and this is what you tell me now here, sine square phi into d phi. Now you can tell me now what I'll get now, q is equal to, so which is equal to 4 by 3 into what I'll get, you tell me now, I can say this is pi by 2, so I will come it as 2 by 3, and this value we have a 4, and we know this property of this thing, Wallis theorem, Wallis formula, that is 4 into, we can say this as what, tell me now, 1 by 2 into pi by 2 now. Now simplify this thing, see what I will get. Here we have 4, this 4 will get cancelled. Now which will come to be a what, tell me now here, 8 pi square. So I will come it as 8 pi square by, okay, this 2 also will get cancelled. So then will be 4 pi square. 4 pi square by 9. So units are what, tell me now, nanocoulombs. Got it? Next one. Next, electric flux. Electric flux. What this electric flux means? These are the imaginary lines. Electric flux is nothing but imaginary lines. For example, I have taken some positive charge. We have taken. This is a positive charge. Now, here if I place one more positive charge, then you tell me now what will happen. And we have these electric lines like this, and same manner this electric, so here we have like this. Now the charge will experience a forces in all around the charges like this, right? So you can see now all around the charges we have these forces. Okay, isn't it? These lines are called as electric field lines or electric flux lines. These lines are called as what, tell me? Electric flux lines. These lines are called as electric flux lines. And these flux lines will give the direction of electric field. These electric flux lines will give the direction of the electric field. Okay. These imaginary lines, the imaginary lines drawn from the surface of the charge, which indicates the direction of electric field, are called as the electric field lines or the flux lines. Electric field lines are the flux lines. Okay. Now let us talk about the properties of these flux lines. How these electric flux lines are continuous and smooth curve. Continuous and smooth curve originate from the positive charge and terminate on the surface of the negative charge. If the negative charges are not available, what happens? You tell me now. The electric flux lines will travel infinite distance. The flux originating from a charge is independent of the surrounding medium. electric flux lines never intersect. The electric flux lines are closely spaced at the locations of high electric field and widely separated at the locations of low electric field. And so the tangent will use the direction of electric field. Tangent will use the direction of electric field. The amount of electric flux originating or terminating from the charge is equal to magnitude of the charge. Okay. That means if we have 1 coulomb of charge, इसका मतलब is what, tell me now here, 1 coulomb of charge, 1 coulomb of charge gives how much flux? 1 coulombs of flux, 1 coulombs of electric flux. Okay. Next. So that means if we have a minus 1 coulomb of charge is there, then what happened? Minus 1 coulomb of charge takes 1 coulomb of EC electrical दोनों के लिए 1 coulombs of electric flux. Electric flux lines, if it is a positive charges will give the flux, negative charges will take the flux. Yes, this is helpful for both EC and electrical दोनों के लिए. So here, so first we'll finish the common topics of EC electrical. इसके बाद we'll do the केवल EC का part will do it. इसके बाद so EC का topic will do. First we are doing the common topics of both EC and electrical का. Next, electric flux density. Yeah, we'll continue करेगा daily like this. Daily like this we can continue. So actually today it was because of some network issue, it was become little late, and so from tomorrow onwards regularly we have a 2 o'clock only we have a session. Okay. Electric flux density. And what is the electric flux density D? We already seen this thing here, which is given as what, tell me now, this is the ratio of electric flux per surface area. Electric flux per surface area, which is called it as a electric flux density. And this electric flux density D, which is given as what we can say now here, that is d psi by ds, and the direction which is given as n cap with a units of coulombs per meter square. Okay, we'll try it. Mostly we'll try to finish. फरवरी के पहले कंप्लीट करने के लिए हम कोशिश करेगा. So that means, so this pipe which could be given as, that is integral of surface integration of d bar dot ds, and with a units of coulombs. And so this is called it as what, tell me now here, electric flux. This is called it as a electric flux through the open surface. Here we have taken open surface integral now. That's why this is called as electric flux through open surface. If I want the electric flux for closed surface, we should take it a bubble will take. So d bar dot ds. Now this is the electric flux through closed surface. This is the electric flux through closed surface. Okay. So this is that depends upon the what type of integration we have taken. Here we have taken open surface integral. That's why electric flux to open surface. If I want the flux to a closed surface, we should take the closed surface integral. Next, Gauss law. And what the Gauss law is, the net electric flux leaving through any closed surface is equal to total charge enclosed by the surface. So iska matlab is, what tell me now here, consider this is some closed surface we have taken. Closed surface means what? What is meant by closed surface? It should have a volume. It should have a volume. Closed surface means it will have a volume. Consider this is some closed surface, and this closed surface will have some charges are present. Means let us consider we have a 2 coulombs of charge, minus 3 coulombs of charge, and 4 coulombs of charge is present. Consider. Now what they are saying here, so here from the 2 coulombs of charge, what I can say now here, some flux lines will come. How many flux lines will come here? 2 coulombs of flux will come. For easy simplicity purpose, let us consider from 2 coulombs of charge, 2 flux lines will come. So that means यहाँ से 2 flux lines are coming. And here 4 coulombs of charge, it will use a 4 flux lines. 1, 2, and this is 3. And so then minus 3 coulombs of charge, it will take 3 coulombs of lines. 3 lines will take. This one line will come and terminate here. This one more line and come and terminate here. Let us say this line will come and terminate here. So how many lines are left out now here? The remaining lines will move outside to find the negative charges for the termination purpose. So you tell me now how many lines are leaving outside? 3 lines are leaving. So that means one line is equal to 1 coulomb we call now. So that means in that sense the flux leaving the closed surface is how much you tell me now? 3 coulombs. Now if we talk about what is the total charge inside, you tell me now total charge inside the closed surface. We have a 2 coulombs is present. Next 4 coulombs is also inside, and minus 3 coulombs is also inside. So then how much the charge now? Net charge inside is what? Tell me now. 3 coulombs only now. So you see this thing here, the flux and Q enclosed both are equal. So from this we can conclude. So that is the net flux Q, which is equal to what? Tell me now here, Q enclosed, which is equal to Q enclosed. Is this point clear to everybody? Okay. Now, so this thing. So this is from this we can say net flux, which is equal to what? Tell me now, Q enclosed. Right. Now you can see now here how we can analyze this thing. So now this is the flux according to the flux density. Flux we can write in terms of flux density. Since we have a closed surface, will be taken as closed surface integral. Closed surface integral of d bar dot ds. Right. Next, now we will find the Q enclosed. Since it is a closed surface, will have volume charge. So the Q enclosed is what I can say, that is volume integration of rho v into dv, volume integration of rho v into dv. Is it fine? Now from this, by equating them here, we can see it as what? Tell me now here. From this, by equating this thing, so the flux which is equal to, we can say now here, closed surface integration of d bar dot ds, and that equal to what? Tell me now here, Q enclosed, and so that equal to what we have? Tell me now here, we can say this as rho v into dv. Is this thing is fine to all of you? Right. Done. Now we are equating these two. So this means if I equate these two, so you can tell me now here, we will get it as closed surface integration of d bar dot ds, and which is equal to what we can say now, rho v into dv. Now you can see now left side we have the what type of integration is there? Closed surface integral. Can you convert the closed surface integral to volume integration? By using divergence theorem. So tell me now, apply the divergence theorem here. This is volume integration of what I can say. This is del dot d into dv, and which is equal to, yeah, tell me now here, this is volume integration of, this is rho v into dv na. I can equate these two integration both sides. Both sides we have same volume integral solely na. So from this we can write it as what? Tell me now, del dot d, which is equal to what we can say? Tell me now, rho v. Del dot d, which is equal to what you can see now? Rho v. All of you. So then we got this equation. What we can say now? This is called it as the Maxwell's first equation. Del dot d, which is equal to rho v, and this is what you tell me now here. This is a Maxwell's first equation. Okay. Next. And so this amount of electric flux will come now. The electric flux will depends upon what? Tell me now here. Upon the charges present inside the closed surface, the electric flux independent of the outside charges. Electric flux independent of outside charges. Okay. So means we have taken, this is my closed surface. Inside we have a charges is there. Let us say we have a 3 coulombs of charge, minus 1 coulomb, minus 4 coulombs, and here we have a 2 coulombs of charge is there. So what is the flux now here? The charge lies outside now, outside my closed surface. The electric flux will depends upon what, tell me now here, the charges present inside the closed surface only. It does not depends upon the outside charges. So this is outside. So then electric flux independent of outside charges. So how much is answer, you tell me now? 3 plus 4 coulombs minus 1 coulomb. So that is equal to how much, you tell me now? 6 coulombs only. Okay. Electric flux independent of outside charges. Next, Gaussian surface. Gaussian surface means what? It is nothing but imaginary closed surface over which Gauss law is applied. So, in case of a point charges, if we have a point charge is there for point charges, Gaussian surface is a sphere. And for in case of a line charges, Gaussian surface is a cylinder. And for surface charges, so it is a cuboid. And for volume charges, and which is sphere. Okay. Next, take this problem. Find the electric flux passing through a sphere of radius 2.5 meters centered at the origin. Given the point charges given as this much, the charges located at these locations they given. Okay. So, and they given a sphere. The radius of the sphere they given. How much they given? The radius of the sphere they given as what, tell me now? Radius of the sphere which is given as a 2.5 centimeters. So this is a 2.5 centimeters, and so I can say this is my y-axis. Right. So look at now charges located. Where the charges located now here? On, so this x value. So x is equal to charge they given as how much now? That is given as 2 power minus x square microcoulombs. So the charge is not a fixed charge, which is a variable charge. When x is equal to 0, what happened, you tell me now? That is located at the origin. So this is at x is equal to 0. How much the charge now here? Here this is x equal to 0. How much the charge here? This is 1. So this we have. This is here one charge. And x is equal to 1 plus 1 minus 1 also. So this is x is equal to 1 and this is x equal to minus 1 plus 1 minus 1. Next, at x is equal to 2, we have a charge is there. And this is x is equal to minus 2. Next, x is equal to 3. Where is the charge will lies now here? Outside. Here the x value 2.5, x is equal to 3 lies outside. X equal to minus 3 also lies outside only, right? So we need to consider charges lies inside only. If I call the charges only we need to consider. Now you tell me now here, according to Gauss law, The flux is equal to what we can say, tell me now here, Q and closed. Flux equal to Q and closed. Tell me now flux now here, Q and closed. When x is equal to 0, we have one charge. How much this value? X value 0. So we have a 1 to power 0, 1. Next. Yes, now x is equal to 1. So that is 2 power minus 1. X equal to minus 1 also 2 power minus 1 only. X is equal to 2. 2 power minus 4. X equal to minus 2, that is minus 4. So that means how much will be the flux? You can see now here 1 plus, this is 1 by 2 plus 1 by 2 plus what we have, tell me now here, 1 by 16 plus 1 by 16. So how much this value of flux, you tell me now finally? That is 2.125 microcoulombs. This is, here the charge lies outside now. These are not to be considered. We need to consider the only charges lies inside only. Right. So this one, this is the sphere. Here this sphere, which we can say this as a Gaussian surface. Next one. And you can see now here, a charge Q is enclosed in a spherical Gaussian surface of radius r. If the radius is doubled, then what happens to outward flux? What happens to outward flux? You tell me now. Doubles 4 times, remains same. So this is remains same. The electric flux will depends upon the charges present inside the closed surface only. It does not depends upon surface area. Okay. Next. Take the next one. 4 charges lie along x-axis at n, 0, 0 with n is equal to 1, 2, 3. If the charges given as n factorial into q, then which charge contribute maximum and minimum electric field strength at the origin? Now see what they given, you can see here. So the charges has located along x-axis. Okay, so this is on x-axis. At x equal to some different location they given, right? So you can see now here, so when x is equal to 0, so x n value 1 will start now, x is equal, so here this is the origin 0, 0, 0. X value, so this is what, tell me now here, 1. So this is what we'll get now, 1, 0, 0. Next, when n is equal to 2, you tell me now this is 2, right? Is it fine now? Now tell me now at a, so this is at x is equal to 2, 0, 0. How much we can see this thing here? This value 2 factorial means we can say 2q only now. Next, when n is equal to what, tell me now here? So this is 3 comma 0 comma 0. 3 factorial means 6. So that is 6q. When n is equal to 4, that is what we can say 4 comma 0 comma 0. So that is how much we can say 4 factorial means 24. 24q. Due to all these things, we need to find what, tell me now here. We need to find the electric field at the origin. We need to calculate, right? So then let's find the electric field at the origin. Now, so here electric field. So we are calling this as charge 1. Let us the second charge. This is my third. This is the fourth charge. So tell me now electric field at point at the origin because of first charge. So this is E1. So how much will come, you see? E1, which is given as what we can say now KQ by R. That is 1. Next, what I will get, you tell me now E2. That is K into 2Q by R. R square means what, tell me now 2 square will come it as 4. So will come it as 1 by 2 KQ. Next, what we can say now E3, which is given as KQ, that is 6Q by R square, that means 9. So we'll come it as what will be now 2 by 3 into KQ. Next E4, which will come to be a K into, this is 24Q by 16. So how much this value will come here? 3 by 2 KQ. So now you can see now from this which is a minimum, which is a maximum you see. And here 3 by 2. So this is 1.5. This is a maximum now. And this 0.5. This is minimum. So second charge is minimum and fourth charge is maximum. Okay. Next. 2-point charges 5 coulombs and minus 5 coulombs are located at 0, 8, 0, 0, minus 8, 0 respectively. The direction of electric field at point X, 0, Z is. Okay. So we have the charges located where you can see now here. Here we have this is 5 coulombs of charge at 0, 8, 0. The next one is minus 5 coulombs. That location is 0, minus 8, 0. Due to this, we need to find the electric field at the point of X, 0, Z we need to find. So due to this is the electric field here like this. And because of this, the electric field is like this. So this we are calling this as a E1 and this I am calling it as E2. You see this magnitudes are same, the only the thing difference will come it as what, tell me now here. So that is magnitude is same, but only the difference you can find is directions will be different. So if we talk about this direction, if I call it as a, so R1 bar, here this direction is R2 bar. So what is this R1 bar will come, you tell me now? That is Xi cap minus 8J cap plus Zk cap. Right. So from this we can say this electric field formula, which I can say this as, so this value K into Q into, we can say this as R bar. So this one, so the remaining terms will be taken as constant. That is 1 by 4 pi epsilon naught. That is what we can say now, Q by R cube into R bar. This term is a constant we have taken. So finally we are writing it as E, which is equal to what? Tell me now. KQ. So this is KQ into R bar. So that is E1, which will come to be a K value. KQ is 5 into R1, that is Xi minus 8J plus Zk. Now similarly, what I can say now, E2 value, that is minus K5 into Xi. R2 value we didn't calculate. R2, how much is R2 value? Tell me. So this is Xi plus 8J plus Zk. So this Xi plus 8J plus Zk. So this means we add this thing here. E will come to be a what? Tell me now here. You can see this is E1 bar plus E2 bar, and which will come to be a 5K into common. This is X will get cancelled. Only 8 into 8, 16 will come. So that is this value minus 16 will come. This value come to minus 16 J cap. So from this, which I can write as what? Tell me now here. 80K into minus J cap na. So we can say negative Y directions. Right. Next. And take this next problem. Concentric spherical shells of radius 2m, 4m, 8m carry uniform surface charge densities. They given. Okay. Now I have a 3 spheres. They given 3 spheres will have a different. Consider this is one sphere and this is the another sphere. Another sphere and this is another sphere, and these are the concentric spheres. Okay. Now here this radius they given us what? Tell me now here. If I call this as R1, which is equal to 2 meters. This will have a charge density. How much they given? 20 nanocoulombs per meter square. And this radius, and which is R2, which is equal to what? Tell me now. 4 meters. And this value is what? Tell me now. Minus 4 nanocoulombs per meter square. And this radius, which is radius is 8. Let us say this is R3, which is equal to 8 meters. This will have rho s. Rho s they given. So let us call the charge. I am calling it as a Q1. How much of Q1 surface charge now? So that means rho s value 20 nano into 4 pi r square. 4 pi into r square means r1 square. So will come to be a what? Tell me now here. So this is 80 pi. So this value 80 pi. So this is 4 pi. Okay, we'll write directly here. This is 80 pi into r square. How much this value? Tell me now. 4. So this value how much will have? So this is 30 to 320 pi nanocoulombs. and this is Q2 value, which will come to be a minus 4 into what element of 4 pi r square. So that means 16. Okay. How much this value will come? How much the charge? So 16 is now here. So Q2, which will come to be a minus 256 pi nanocoulombs. And here this is charge is Q3. How much is value? Rho s into 4 pi r square. That is 64 na. So this value, how much you tell me now? 256 only. 256 pi into rho s. Now, see what they given now. These are the concentric now. So we need to find the electric field at the given locations. 1, 3, 5, 7 we need to calculate. So this is the first one. Next. And this is the next. This is the next one. Concentric spheres. So this one radius, which is R1, and this radius is R2, and this radius is R3. Okay. So this having a charge is Q1, this charge is Q2, this charge is Q3. Now let us find out the electric field now here. So what the electric field formula? E is equal to what, tell me now? So we can say field of flux density they are asking, tell me. Electric flux density, okay. Electric flux density formula is what, tell me now? D na. So D is equal to what, tell me now here? Q enclosed by 4 pi r square into AR cap. Okay. So first we are finding at where you tell me now, at r equal to 1 meter. At r equal to 1 meter, find the Q enclosed now. How much the Q enclosed? Which is equal to 0, isn't it? So 1 meter, this R1 is 2 meters now. So inside 1 meter means we should take the Gaussian surface inside. At that location, how much the Q enclosed value? 0. If the Q enclosed is 0, so that how much the D value, tell me now? Which is equal to 0. Next. Now you can tell me now at R equal to 3 meters. Here you tell me now 3 meters, we take the Gaussian surface now. When you have taken this 1 meter, we have taken Gaussian surface, which we got it as a 0 here. When you have taken at 3 meters here, this pink one is a Gaussian surface. This is a 3 meters. With this 3 meters, so you can see now here, with this C is a 3 meters. For 3 meters, so how many spheres are inside? Only one sphere is inside. So that means how much the Q enclosed, do tell me? Which is equal to Q1. How much the Q1 value? Q1, which is equal to 325 nano. So which is equal to 325 nanocoulombs. Then we can find this D value, tell me now. That is what, tell me now? 320 pi by what, tell me now here? 4 pi r square. R value 3 na, 3 square 9. So this value AR cap, this is nanocoulombs per meter square. And we do the simplifications. Okay. Next one, we need to find at R equal to where now here? 7 meters. At 7 meters, how many spheres are inside? You tell me now. 7 meters. So 2 are inside. So the 7 meters here now. Yes. Here 7 meters. And this is, so now in 7 meters you can tell me now here how much the 𝐶 you tell me now. 𝐶 2 are inside, that is Q1 plus Q2 now. So how much this value Q1 plus Q2 value? So 320 minus 256, isn't it? How much now here? 320 inside minus 256. How much will come here? This is 320 pi minus 256 pi. So how much the 𝐶 you tell me now here? That is 64. That is 64 pi. 64 pi nanocoulombs. Now you can see this thing. How much the 𝐶 now tell me? How much the 𝐶 64 pi. So then from this we should find electric flux density D, which is equal to what? Tell me now here. 64 pi by 4 pi r squared means what? Tell me now 49. So that is nanocoulombs per meter square. Next. So now where we need to find and R equal to, okay, 5 also we need, okay, 5 also. So 5 meters. So how many charges inside now here? 𝐶 is Q1 plus Q2. Here also 2 charges are inside only now. So that means how much will come? 64 pi nanocoulombs. Then what the D value? Tell me now here. 64 pi by 4 pi into 25, that is nanocoulombs per meter square. Okay. Next. This is the first bit, and second bit is they ask you to find the value of ρs so that D is equal to 0 and R equal to 10 meters. So we'll try to find same man at R equal to 10 meters we need to find. So what they're saying here, at R equal to 10 meters, what they're saying here, D value 0. What the D formula? Tell me now here. That is 𝐶 by, that is 4 pi r square. So this equal to 0 means 𝐶 is 0 now, tell me. And 𝐶 is 0, that means in this case how many charges are inside? You tell me now here. Q1 plus Q2 plus Q3, and which is equal to 0. Which is equal to what I can say now? 320 pi minus 256 pi plus 256. These are the nanos, na? Okay. These are the nanos. Okay. Q1, Q2, Q3, these are nanos, but this is not a nano. Okay, remember. Yes, 256 pi into ρs, which is equal to 0. So that means how much will get this ρs value? Tell me now here. Which will come to be a 1 by 4. that is nanocoulombs per meter square. 1 by 4. Isn't it? Check it, all of you. Minus 1 by 4 plus 1 by 4. Right? Next one. Work done. Work done is what, tell me now here. So this means work done to move the charge base. The work done is equal to what, tell me now? That is integral of force into displacement. Integral of force into displacement. So this work done, the force which is given as electric force QE dot dl. This is the work done. Now, so Q is constant, we have taken outside. This is Q into integral of line integral of E bar dot dl. This is the work done. So work done by the electric field. Work done by the electric field. So that is W, which is equal to Q into integral of line integral of what, tell me now? E bar dot dl. And if they are asking the work done against the electric field, work done against the electric field, and so this is which is equal to minus Q into integral of what we have, tell me now? E bar dot dl. Okay. Next, potential difference. Potential difference is what, tell me now? Work done to move the charge from one point to another point against the electric field. So this is potential difference. We can call it as VAB, and which is given as work done by charge is called as a potential difference, VAB. So this means which is given as VA minus VB, and this potential difference VAB which is given as, that is Q by 4 pi epsilon into which we have 1 by RA minus 1 by RB. This is the potential difference. And potential is what, tell me now here? Work done to move the charge from one point to another point, infinite to required point. That is called as a potential. Potential which is given as integral of minus from infinite to required point of what we can say now? E bar dot dl. This is called it as a potential. And potential which is given as, which we can say this as KQ by R. Potential which is equal to KQ by R. Okay. Done. Now, if we ask the potential difference between 2 points A and B, so that is VAB, which is equal to what? Tell me now here. Minus integral of, this is A to B, E bar dot dl. And what about the VBA? That is given as integral of B to A, E bar dot dl. So if I add this thing, so what I will get, you tell me now here, that is VAB plus VBA, and which is equal to minus integral of A to B of E bar dot dl minus integral of B to A E bar dot dl. So then we can get it as VAB plus VBA, and which is equal to, we are doing a closed path integration. This value 0 na. So that means what we can say here, closed line integral of E bar dot dl, which is equal to 0. We are moving from A to B. Again we are come back to B to A. This is a closed path. Closed path integration is 0. So from this we got the relation as what you see, that is closed line integral. Closed line integral of what? Tell me now, E bar dot dl, which is equal to 0. So we can apply the Stokes theorem. Then we can say this as open surface integral of del cross E dot ds, which is equal to 0. From this we can say this as del cross E, which is equal to 0. So this is the second Maxwell's equation. This is the second Maxwell's equation. Okay. From this we can write it as what? Tell me now here. What is the nature of the electric field? Is irrotational. Curl of electric field is 0. From this we can say electric field is what nature? Irrotational field. Electric field is irrotational. Irrotational. And we can also call it as a conservative. Electric field, static electric field is a conservative field. Okay. Now, so you can see now we have the potential V, which is equal to what? I'll be minus integral of E bar dot dl now. If I differentiate it, will come it as dV by dl, which is equal to what? I'll be minus E. From this what I can say now here, E is equal to, we can write as minus of dV by dl. E is equal to minus of dV by dl. So this is the relation for the E and V in case of a one-dimensional case. This is in case of a one-dimensional. If it is a three-dimensional case, the relation we can write the vector form, we can write, which is equal to minus of dou V by dou x into I cap minus dou V by dou Y into J cap minus dou V by dou Z into K cap. So from this we can say that E is equal to what we can say here, minus del V. E equal to minus del V. Right. So from this we can say, write it as what, tell me now here. So the static electric field we can write it as what, tell me now, gradient of a scalar potential E. So that is E equal to what, tell me now, minus del V. And where this minus sign indicates that what, tell me now, the direction of electric field is, the direction of electric field is opposite to the so we can write as direction of electric field is decreasing direction of potential, decreasing direction of potential, decreasing direction of potential. Okay. Next. Next. Conductor. What is a conductor? Tell me now. Basically, conductor means what? Conductor, it has the ability to allow the flow of charges, but without giving any supply, it cannot provide, it cannot allow any flow of current, which is capable to allow the flow of current when the supply is given. Here we are talking about the conductor is what type of conductors are? Isolated conductor. Isolated conductor means what? Conductor which is, for conductor we are not given any supply. There is no external supply. Then we can say that is the isolated conductor. Electrostatic equilibrium means what? Tell me now here. Electrostatic equilibrium means what? So this one, if there is equilibrium means what? No movement of charges. If there is no flow of charges, we can call it as a equilibrium. So no movement of charges means what? No flow of current. So that type of conductors we are discussing here, first of all. Now here, so you see this thing, as we might be know, so if we have taken any conductor, basically we have taken any conductor. For this conductor, if I given some supply is given, then what happens? For this conductor, if I connected this conductor to some supply we have connected, then see what will happen? Supply. Then we have charges are the inside. We have positive charges as well as negative charges we have. Now these positive charges are there, so they will move along this electric field. Negative charges will move this direction, opposite to electric field. Because of this we have a flow of current. And the electric field is this direction, positive charge to negative charge. This is a fundamental phenomena. So now you see this thing, I have taken a same conductor, but I am not at all giving any supply. I am taking the same conductor we have considered, we have taken, but this conductor we are not giving any supply here. If I not given any supply, do we have any flow of current? You tell me now. In this case, do we have any flow of current? No flow of current. No flow of current means what? Tell me now here. There is no electric field. So here, when we apply this one, the charges will experience a force. Force is given as QE. Because of the force, the charges will move. The charges will displace. But here, we are not given any supply. If there is no supply, that means there is no current. No current means no moment of charges now. So that means how much the electric field must be? Zero. So that means what we can conclude, tell me now here. The electric field inside a conductor is how much? Zero. There is no electric field inside a conductor if there is no supply is given. Those properties we are discussing now. Right. And see the first property. The net electric field inside a conductor is how much? Zero. And the net charge inside a conductor is also zero, isn't it? So if we have taken any conductor we have taken, what should be now here? The conductor, basically we have a rich in number of charges, but there is no moment of charges. And what is the electric field inside a conductor? You tell me now. Zero. For this conductor, electric field is how much? Zero. Next. So conductor. So what the conductor will do? It does not allow any charge to enter inside. For example, we have taken this is the conductor. So for this conductor, imagine now here we have placed some 10 coulombs of charge we have placed on the surface. Will the charge can enter inside? No. The charge does not enter into the conductor. The charge does not allow any charge to enter inside. But where the charge will lie, the charge will completely resides on the surface of a conductor only, like this. It will distribute itself. It will distribute like this. It will distribute itself. It will distribute itself such that the entire charge will lies where you tell me now here on the surface only, but no charge can enter inside the conductor. So this is the one phenomena what we can do here. We use the concept called as electrostatic shielding. So for example, I want to protect my something inside. So this is the cavity. The cavity. If I place my some object in this now, so what happens now here? This cavity is protected. So this concept which is called it as a electrostatic shielding. This is called it as what? Tell me. Electrostatic shielding. Okay. This is called it as the electrostatic shielding. No charge can able to penetrate inside. The electric field at any point on the surface of the conductor. Electric field at any point on the surface of the conductor. How it is? So the electric field at any point on the surface of the conductor which is normal. Electric field at any point on the surface of the conductor which is okay. Next, potential. Potential due to the concentric spheres. Now you tell me now potential here on this inside this radius is we have RA and this radius is RB. So this VA which is equal to what, tell me now here, that is 𝐾𝐢𝐴 by RA plus 𝐾�QB by RB. Next, what about the VB, you tell me now, that is 𝐾�QA by RB plus 𝐾QB by RB. Okay. Now tell me for three case, and what is this VA, tell me now here, 𝐾QA by RA plus 𝐾QB by RB plus 𝐾QC by RC. Next, VB equal to 𝐾QA by RB, we are finding here, plus 𝐾QB by RB plus 𝐾QC by RC. Next, VC 𝐾QA by RC plus 𝐾QB by RC plus 𝐾QC by RC. Okay. Right. This we already seen now. Yes. Now take this problem. Consider the following statements associated with the basic electrostatic properties of ideal conductor. The resultant electric field is 0. Yes, the electric field inside a conductor is 0. The net charge density in the inside is 0. The net charge reside on the surface. Yes. Surface is equipotential. Yes. The field just outside. No. The field just outside is non-zero. So which are correct statements are 1, 2, 3, 4 are correct. One, two, three, 4 are correct. Okay. Yes. Okay, fine. That's it for today's sessions, and the remaining next about this magnetic fields and all we'll discuss in the next class. Okay.